jumping right back into our graphs of sine and cosine, we're going to look at two separate graphs, one that has a change in the amplitude and one that has a change in the period. As we saw in our notes and in the previous video, our standard equations are normally y equals a sine bx as well as y equals a cosine bx. So we're going to see what changes whenever we have a value other than 1 in those equations. So let's look at this first one. Y is equal to -1/2 sine x. Now I don't see anything different for the b value, so that means my period for this equation is going to stay just like it is. So if I took 2 pi over b, that would just be 2 pi over 1. So that's going to stay the same as the period. And what that's saying is we're going to have one complete cycle that goes from this distance of 0 all the way to 2 pi. So we'll be able to see a full wavelength that has a crest and a trough with it. And then looking at the a value, knowing that we have our absolute value of a, if I plugged in -1/2, I know that my amplitude is going to be 1/2. And what that's representing is the highest I can go is going to be 1/2, and the lowest that I can go below equilibrium is going to be 1/2. So that's going to be really important. And the other thing I would take note of is this little tiny negative right here. What that negative is representing, if we think back to our first semester in transformations, it means it's going to reflect across the x-axis. Our normal sine curve, if I erased these values here, if I can do that and get a different color here, we know that sine is going through 0, 0. It goes up to 1, and then down to -1 and back to 0. So we have this curve that goes right along there. That's one complete cycle. And I'm actually going to go ahead and leave this in here just for sake of, it helps it to see the picture a little bit better. So that's 2 complete cycles of a sine curve. But now we're looking at what happens if I change the amplitude here and I have a reflection. So let's actually fill out some of this on the chart, knowing that some of these values are just automatically going to be 0. And then a normal sine curve would have gone +1 to -1 on the right side, -1 to +1 on the left side. But look at what I have here now. I have a reflection, which is going to make all the signs opposite. Rather than going up, I'm going to go down. As well, I'm not going to go all the way to an amplitude of 1. I'm going to go to an amplitude of 1/2. So that means if I were to plug in these values, if I was actually taking -1/2 sine of pi over 2, then I would see that I'm going to get -1/2 for my answer here. 3 pi over 2 is going to be +1/2. Then I'm going to go +1/2, -1/2 with these values that I'm plugging in. So as I go to graph this transformation, I'm going to still start at the 0, 0 mark, but I'm going to go -1/2, 0, +1/2, and 0. And then I'm going to back up, see if I can get +1/2, 0, -1/2, and 0. So the yellow graph is what is going to represent, still we have a period of 2 pi, but this time our amplitude is actually 1/2, and our entire graph is reflected across the x-axis. So that's helpful for us to see in that question. And then moving on to y is equal to cosine 2x. So for this one, nothing's changing in the amplitude, but what I do have is a change across the period. So amplitude is still going to be 1, just like the original. And I might even go ahead, let's do our different color again, and let's remember what the cosine curve looks like. We know that it's going starting at 1 on the y-axis. That one's not super close. And then go back the other direction. And fill that out. So that's an original cosine graph with a period of 2 pi. But now for this question, I'm changing something about the period. If I take 2 pi over the absolute value of b, something's going to change here. I'm going to get a period of pi, which means that what's actually going to happen here is I need to have an entire cycle, crest and trough, that occurs within that space right there. So it's definitely what we have when we think of a horizontal compression, where it's going to push all of that together. What would normally fall between 0 and 2 pi is actually going to fall between 0 and pi, which actually brings me to something really, really important. If that's true, then this chart that I have below here does not work to give me the values that I'm looking for. It's too spread out and probably won't get me some specific values. So what I'm going to do is I'm actually going to go to a different chart that I've already set up, where I'm going, rather than negative 2 pi to positive 2 pi, I'm going to go negative pi to pi. So those values are really, really important as we're working through this. So if I were to take on each of these cosine 2 times 0, so what is cosine at 2 times 0, or basically at 0, we know that the x value is going to be 1. So then I'm taking cosine of 2 times pi over 4, plugging those in. So then I'm going to look at, okay, what's cosine at pi over 2? It's going to be 0. So some things are going to change, some things may stay the same, but it is going to allow me to be able to see how everything is really truncated into a smaller area. If I were to take and go the other direction, cosine of 2 times negative pi over 4, well, that's going to give me negative pi over 2, which cosine at negative pi over 2 is 0. So if I were to fill the rest of this out, and you could even stop this video and go ahead and finish, I'm going at pi, I'm actually going to have a value of 1. Let me write that off to the side here. And so I'm just rotating or kind of cycling through what I'm used to. I'm normally used to this 1, 0, negative 1, 0, back and forth, but I had to make sure that I had some more specific values in between. I'm actually trying to find what is cosine at these values that on the graph aren't necessarily even marked. That's really important for us whenever the period changes. So now I can go in and graph. At 0, we're at 1, but now at pi over 4, we're at 0, negative 1, 0, and 1. So look at what happens where in the graph before, we had that spread out from 0 to pi. It actually went from here to here. But now in this particular graph, we're going from this point to just that point right there. So it's definitely shrunk in its movement. And I'll go ahead and take it back on the left side. I always like to show a period on the front and the back of the y-axis. So get all that in there. Don't let it look like a V. Be careful with that. You do still want it to look like a curve, although it's going to be really tight as it goes through there. So that's what's happening when we're told that the period is changing, then something is happening to it horizontally, whether it be a stretch or whether it be a compression, to allow it to change some of the values, which means when those values change, then your table of contents, your table of values has to change as well. And I realize that the further we get in this, you'll be doing a lot of these graphs on your calculator, but to start out the first couple weeks here, we will want to graph it by hand, and so that's going to be really important for you to know.